What are the economic minerals? Economic minerals are naturally occurring materials that are extracted and processed for their economic value. These minerals are typically used in industries ranging from construction and manufacturing to technology and energy. Their economic importance stems from their utility in producing goods, generating energy, and enabling technological advancements. Here's a detailed breakdown of the key categories and examples of economic minerals. 1. Metallic minerals. These minerals are the source of valuable metals that are essential for various industries. Metallic minerals include iron ore. The most widely used metal, iron is essential for making steel, which is the backbone of construction, transportation, and manufacturing industries. Copper, known for its excellent electrical conductivity, copper is a key component in electrical wiring, plumbing, and electronics. Bauxite, aluminum or bauxite is the primary source of aluminum, a lightweight metal used in industries ranging from aviation to packaging. Gold. Besides its value as a precious metal, gold is also used in electronics, medical devices, and as a financial reserve. Silver. Similar to gold, silver is used in currency, jewelry, and electronics, as well as in medical applications. Zinc. Zinc is primarily used for galvanizing iron to prevent rust, and it's also a component of brass and batteries. Lead. Historically used in paints and pipes, lead is now predominantly used in lead-acid batteries for vehicles. 2. Non-metallic minerals. These are minerals that do not contain significant amounts of metals but have considerable industrial value. They include limestone, used in the production of cement and as a building material. Gypsum, primarily used in construction for plaster and drywall. Clay, essential for making bricks, ceramics, and as a component in various industrial processes. Silica, quartz widely used in glass manufacturing, silicon production, and in electronics. Salt, halite used in food preservation, as well as in industrial applications such as de-icing roads and water softening. 3. Energy minerals. These minerals are crucial for energy production, which powers industries, homes, and transportation. They include coal, a fossil fuel that is still a major source of energy for electricity generation globally, though its use is declining due to environmental concerns. Oil, petroleum crude oil is refined into various fuels like gasoline, diesel, and jet fuel, and it also serves as the base for petrochemicals used in plastics and other products. Natural gas, used for heating, electricity generation, and as a raw material in chemical production. Uranium, essential for nuclear energy, uranium is used as fuel in nuclear reactors. Bitumen, oil sands, a dense form of petroleum that requires significant processing to convert into usable fuels. 4. Gemstones and precious minerals. These minerals are highly valued for their beauty, rarity, and use in jewelry. However, some also have industrial applications due to their hardness or conductivity. Diamonds, besides their use in jewelry, diamonds are used industrially for cutting, grinding, and drilling due to their hardness. Sapphires and rubies, both are used as gemstones, but they also have industrial applications in lasers and electronics. Emeralds, primarily used in jewelry due to their aesthetic appeal. 5. Industrial minerals. These are minerals used in a wide range of industrial applications but do not fall into the other categories. They include phosphates, essential for agricultural fertilizers that support global food production. Sulfur, used in the production of sulfuric acid, which is a key chemical in industrial processes, particularly in refining and fertilizer production. Mica, used in electronics, insulation, and as a filler in paints and cosmetics. Graphite, crucial for batteries, especially in electric vehicles, and for lubricants and pencils. Boron, used in glass manufacturing, detergents, and in high-tech applications like LCD screens. Importance and uses of economic minerals. Economic minerals are the backbone of modern economies. Their extraction, processing, and use drive many sectors, contributing to the creation of jobs, infrastructure, and technology. For example, construction and infrastructure, minerals like iron ore, limestone, and gypsum are vital for building roads, bridges, and housing. Technology and electronics, metals like copper, silicon, and rare earth elements are essential for manufacturing electronics, smartphones, computers, and renewable energy technologies. Energy production, fossil fuels, coal, oil, natural gas, and nuclear fuels, uranium, are critical for powering homes, industries, and transportation, although there is a growing shift towards renewable energy sources. Environmental and social considerations. While economic minerals are critical for development, their extraction and use can have significant environmental and social impacts. Mining often leads to habitat destruction, water contamination, and air pollution. Furthermore, the mining industry has been associated with labor abuses, displacement of communities, and geopolitical conflicts, particularly for minerals like diamonds, cobalt, and rare earth elements. There is growing emphasis on sustainable and responsible mining practices to mitigate these challenges. In conclusion, economic minerals are indispensable to modern economies and lifestyles, serving as the foundation for infrastructure, technology, energy, and more. However, as global demand continues to rise, balancing the economic benefits with environmental and social sustainability will be key to ensuring their long-term viability. Sonu Dedin. How are economic minerals formed? Economic minerals are formed through a variety of natural geological processes that take place over millions of years. These processes involve a complex interplay of physical, chemical, and biological factors that lead to the concentration of minerals in a form that can be economically extracted. Understanding how economic minerals form helps geologists locate and mine these valuable resources efficiently. Here's a more detailed explanation of the different geological processes that lead to the formation of economic minerals. 1. Igneous processes. Igneous processes are related to the formation of minerals through the cooling and solidification of magma, molten rock, beneath or on the Earth's surface. These processes can lead to the formation of metallic minerals such as copper, gold, and iron, as well as nonmetallic minerals. Subprocesses within igneous activity. Magmatic differentiation. As magma cools, minerals crystallize at different temperatures. This leads to the separation of minerals into distinct layers. For example, heavy minerals such as chromium, platinum, and magnetite can form concentrated deposits in layers known as magmatic ore deposits. Hydrothermal activity. When magma heats groundwater, it creates hot, mineral-rich fluids. As these fluids move through cracks and fractures in the Earth's crust, they cool and deposit minerals like gold, silver, copper, and lead. These are known as hydrothermal vein deposits. For instance, much of the world's gold and silver are found in hydrothermal veins. Pegmatites. These are igneous rocks that form during the final stages of magma cooling and are often rich in rare minerals such as lithium, tantalum, and beryllium. Pegmatites are known for their large crystal sizes and can contain economically valuable gemstones such as tourmaline and emeralds. 2. Sedimentary processes. Sedimentary processes involve the breakdown, transport, and deposition of minerals and organic materials by natural forces like water, wind, and ice. Sedimentary rocks form when sediments compact and cement over time. This process often leads to the formation of nonmetallic minerals, though some metallic minerals also accumulate in sedimentary environments. Subprocesses in sedimentary mineral formation. Placer deposits. As rivers and streams erode rocks, heavy minerals like gold, platinum, and tin are concentrated in riverbeds and along shorelines. These deposits are called placer deposits. Historically, placer gold deposits have been some of the earliest sources of gold for human use. Evaporites. These minerals form through the evaporation of water, typically in arid environments or shallow seas. As water evaporates, it leaves behind concentrated minerals such as halite, salt, gypsum, and potash. These are called evaporite deposits and are economically valuable in industries such as food preservation, fertilizers, and construction. Banded iron formations, BAFs. These are sedimentary rocks made up of alternating layers of iron-rich minerals, like hematite and magnetite, and silica. They were formed billions of years ago when iron dissolved in ancient oceans reacted with oxygen produced by early photosynthetic organisms. BFs are an important source of iron ore. 3. Metamorphic processes. Metamorphic processes involve the alteration of existing rocks due to extreme pressure, heat, or chemically active fluids. These processes can transform minerals into more economically valuable forms or create new mineral deposits. For example, graphite, used in pencils and as a lubricant, forms when carbon-rich rocks such as coal are subjected to intense heat and pressure. Key metamorphic processes. Contact metamorphism. When magma intrudes into surrounding rock, the heat and pressure can alter the rock's minerals, forming valuable minerals such as garnet, talc, and wollastonite. This process typically occurs near volcanic areas. Regional metamorphism. This occurs over large areas, typically associated with mountain-building processes, where rocks are subjected to high pressures and temperatures. Economic minerals like graphite, asbestos, and some types of precious gemstones such as rubies and sapphires form through regional metamorphism. 4. Biological processes. Biological activity has also played a significant role in the formation of certain economic minerals, especially in the early history of the Earth. Living organisms can concentrate or precipitate minerals through biological processes. Biogenic mineral formation. Some organisms, such as corals, mollusks, and foraminifera, form calcium carbonate shells and skeletons, which accumulate over time to form massive limestone deposits. Limestone is one of the most important industrial minerals, used in cement, steel production, and as a building stone. Phosphate deposits, phosphorite deposits, which are rich in phosphorus, are often associated with ancient marine environments where organic matter accumulates. These deposits are essential for the production of fertilizers that support global agriculture. 5. Weathering and surface processes. Surface weathering and chemical alteration play a crucial role in the formation of some types of economic mineral deposits. These processes involve the breakdown of rocks and the concentration of minerals in near-surface environments. Examples of surface processes. Laterites. These are soil and rock types rich in iron and aluminum, formed in tropical regions through intense chemical weathering of rocks. Lateritic soils are a major source of bauxite, the ore used to produce aluminum. Supergene enrichment. Weathering processes can sometimes concentrate metals near the surface, enhancing the value of existing ore deposits. For example, copper deposits in arid regions often undergo supergene enrichment, where rainwater oxidizes copper minerals, creating high-grade ores near the surface. Residual deposits. When less soluble minerals remain after weathering, they can accumulate as valuable deposits. For instance, diamonds found in kimberlite pipes can be weathered out of the parent rock and concentrated in surface gravels, known as secondary diamond deposits. 6. Oceanic and marine processes. The oceans play a critical role in the formation of certain mineral deposits. Many economically valuable minerals precipitate directly from seawater or are concentrated on the ocean floor. Oceanic processes involved. Manganese nodules. These are potato-sized deposits of manganese and other metals like nickel, cobalt, and copper that form on the ocean floor over millions of years. These nodules are seen as a potential future source of critical minerals for the electronics and energy sectors. Marine evaporites. Salt and other evaporite minerals can form in shallow marine basins when seawater evaporates. These deposits are essential for the production of industrial salts and chemicals. Submarine hydrothermal vents, sometimes called black smokers. these vents release mineral-rich fluids from the Earth's crust into the ocean. These fluids deposit valuable metals like copper, zinc, and gold on the seafloor, creating seafloor massive sulfide deposits, which are of interest for future undersea mining operations. Conclusion. Economic minerals form through a wide array of geological processes that occur deep within the Earth, near the surface, and even in the ocean. These processes include magmatic activity, sedimentation, metamorphism, and biological and weathering processes. Each type of deposit is shaped by different conditions, such as temperature, pressure, chemical environment, and time, which dictate what minerals are formed and how they are concentrated. Understanding these processes is crucial for locating and extracting economic minerals, which play a central role in supporting modern industry and technological advancement.